Good afternoon, everybody, and welcome to the webinar of Data Solutions for Industry 4.0. I am Ana Belén González from Atos, and I lead the Impact Dissemination and Communication work package at Ditas Project. Ditas Consortium has organized a series of 2 webinars for end users to learn more about the technologies developed within Ditas Project and technologies implemented in the 2 project use cases. The first webinar that is now is focused on Industry 4.0 use case. Within this use case, Ditas demonstrate how it is easy to develop, deploy, and maintain applications, able to manage the significant amount of data produced by sensor and actuators installed on manufacturing plants. And on the other hand, the other Ditas use case shows the possibility to easily develop applications able to process and to move clinical data from the premises to the cloud environment while ensuring the compliance with the published data, especially with the security and privacy issues. So please stay tuned and join next webinar that will be published in our website and social media. For this webinar, IDEKO, partner of Ditas Consortium and working in manufacturing sector, will present the current barriers and challenges that this sector faces to implement industrial Internet of Things using edge and cloud computing solutions, and how Ditas outcomes can help them to address this challenge. So before starting, let me introduce the speaker. Henry Pages from Atos is Ditas project coordinator, and he has more than 12 years of experience in national and European research projects under different research topics such as grid computing, service-oriented architectures, virtualization, cloud computing, autonomous IT, and energy efficiency in data centers. And currently he is a technical leader of several IT research and innovation initiatives in Atos, Spain. Pierluigi Plevani is assistant professor at Politecnico di Milano and the scientific coordinator of Ditas, where in particular he is currently investigating the role of the data movement guided by a goal-based model. And now Pierluigi is involved in many Italian and European projects. His research is currently mainly focused on information logistics, info computing, in the adoption of IoT in business process management, and he is author of more than 70 journal and conference papers. And finally, Aitor Fernandez is responsible of Ditas Industry 4.0 use case and project manager at IDEKO. His work is mainly focused on architecture and web-oriented software development and software-related innovation technologies. His main areas of expertise are machine learning, cloud computing, software development, and user experience design. The agenda for this webinar is as shown and will consist in 3 main parts: an introduction to Ditas project, and Rich will present a project overview. Pierluigi will introduce Ditas outcomes, and Aitor will present the Industry 4.0 use case. And we will finish the webinar with questions and answers sections. So let's start, and I give the floor to Enrique.
Okay, thank you, Ana Belén. My name is Enrique Pages, and as Ana Belén just commented, I'm Ditas project coordinator. First of all, and very briefly, I would like to introduce you Ditas project. Ditas is a research and innovation action project funded by the European Commission in the 2016 call under the topic of cloud computing. Ditas is a 3-year project, which the main goal is to investigate how to better handle data-intensive applications on top of cloud and fog environments. And the project is focused on 2 main research challenges related with data and computation movement across these mixed computing environments. Moving forward, the next slide shows the different organizations involved in the project. Ditas is composed of 8 partners from 5 different European countries: Spain, Italy, Germany, Greece, and Switzerland, and an associated one, Israel, representing South and Central Europe. The project is well balanced between academia and industry partners. From the industry side, 2 major big players such as Atos and IBM are involved in this project. Atos from Spain coordinates the project and its exploitation, and as well as this organization is also involved in the development of Ditas execution environment. In the other side, IBM from Haifa in Israel is contributing on the research for efficient data storage in mixed computing environments, and on how to access this data in a secure way following the different regulation policies among the different countries. Another industry partner in the project is Cloud Sigma from Switzerland, who provides the testbed resource for the project, and their technical contributions are mainly focused on the data movement research topic. On the other side, we found the academia partners. From the academia perspective, we have Polimi in Italy, who is the scientific coordinator of the project, and they are involved in several technical activities related with the area of adaptive service engineering, in particular in modeling and optimizing quality in the data and services. Technical University of Berlin from Germany, it's also part of the project, of Ditas project. Their main contributions are focused on data monitoring and cloud service benchmarking. ICCS in Greece contributes to the implementation of the abstraction needed to access and process the data, which come from heterogeneous data sources, and also comes in different formats. Additionally to the partners that I have been already mentioned, we have 2 final users who bring real use cases for validating the findings of the project. IDEKO from the Basque Country, who provides an Industry 4.0 use case. You will get more details about this one across this presentation. And then another final user is OCR, Ospedale San Raffaele in Italy, who provides a use case on e-health sector. In the next month, possibly in September, we are going to prepare another webinar about this use case as well. Moving forward, this is the next slide. This slide covers the objectives that the project wants to achieve. First of all, the improvement of productivity when developing and deploying data-intensive applications, and also enhancing the data management in mixed cloud and fog environments, adding data and computation movement capabilities to the applications. As an objective, we also want to define strategies for improving the execution of data-intensive applications, taking into account the security policies and being compliant with the different regulations. Ditas also offers a set of tools for enabling the execution of data-intensive applications in mixed cloud fog environments. And last but not least, maximize the impact on the business. We are going to do that through the validation of our findings on top of 2 real use cases, as it was already mentioned earlier in an Industry 4.0 use case and e-health use case. Okay, this slide shows where we are now. As you can see in this roadmap, the project starts with a design and a specification phase that produce the design of the Ditas architecture and the detailed component specifications at the end of month 9. After this initial phase, the project was divided in 2 major development cycles. One finishing on month 18, where we released the first version of Ditas, and the other one finished on month 30, delivering the final version of Ditas. We are now on month 31, covering the last 6 months of the project, where the main tasks are the verification and validation of the data solution performed by our use cases, and as I was mentioned, and the exploitation of our project results during this final period. Moving forward, the figure in this slide depicts the different actors that could be interested in the data's findings. We divide them in, as you can see here, in 3 categories. And then we can find application developers, software architects, or system integrators, which are involved in the development of data-intensive applications. It could be also interesting for data source owner or data analysis that wants to offer data in a secure and reliable way through our platform. And it can be also interesting for hardware vendors, such as IoT providers, to enable them with the benefits of the edge adoption. And finally, we target also cloud and edge providers, as well as possibly independent software vendors that would like to integrate their offerings with our solution. Moving forward, and in my final slide, I would like to highlight some of the achievements of the project during this period. I will go through them quite quickly, as them are going to be covered with more detail during the next slides. As part of Ditas solution, we are offering a way to define what we call in Ditas VDC, Virtual Data Container, which offers an uniform interface to access the data and defining the data and computation movement strategies to be applied. We release as well a software development kit which support the creation of these aforementioned VDCs. In addition, we release as well a set of software components that compose the data, what we call the Ditas execution environment. The software modules are released, most of them as open source, and they are accessible from our public GitHub repository. So stay tuned to that repository in order to get the latest version of our models. And finally, we produce several press releases, reports, and research papers that you can find in our project website, ditas-project.eu. And that's all from my side. And now I will give the floor to my colleague, Dr. Plevani, who is going to cover in more detail Ditas outcomes.
Okay, thank you, Enrique. Let's move to project outcomes. As said, I give the floor to Pierluigi.
So thank you very much, and good afternoon from my side as well. I would like in this, let's say, 5 to 10 minutes to introduce you the main outcomes of the project. As already Enrique was saying, we are almost at the end of the project. It's a 3 years project, and we are in the month 31. And most of the work has been done, and we are running now in the validation phase. Before introducing the main elements of proposed by Ditas, I would like to specify which is the environment, the main domain that we are taking into account. And in particular, we are taking into account 2 domains, the fog computing and the data-intensive applications. It is also highlighted by the title, by the name of the project. Indeed, we are talking about data-intensive application, first of all, because the data-intensive application are quite important in the Industry 4.0 scenarios. Indeed, there are a lot of data that has been generated by machineries and also by the organization in the large, and they are mainly produced by the edge of the network, by devices that are living inside the organization. But most of the time, this data cannot be computed internally because they require a lot of resources that nowadays are mainly made available by by cloud resources. For this reason, this data has to move to the cloud, then processed there, and then the result will move back to the edge in order to be presented by the final users. There are also some situations, especially in the Industry 4.0, where the data that has been generated and furtherly processed can be consumed by external organizations, by external actors. So in this way, we have a situation in which we have one, let's say we call it the data owner, one data owner that produces and exposes the data, and many potential data consumers that based on their own application, they are able to consume and furtherly, again, process this data in order to fulfill their own internal tasks. This approach brings too many limitations, especially because of the influence that the network has in the different data transmissions. Indeed, when we move data from the edge to the cloud and the vice versa, we can have an important role. We can have a lot of affection from the latency of the network. For this reason, the fog computing has been recently proposed by different organizations, at the beginning from Cisco, and then has been established by a consortium that is called Open Fog Consortium, that proposes this novel paradigm that tries to create a continuum between the cloud and the edge, exploiting also the devices that are living in the middle between these two environments. For this reason, in this way, we are able to exploit, to reduce the latency, because we try to move the computation closer to where the data are generated. But sometimes this approach doesn't work for different reasons. First of all, the computation is limited at the edge of the network because the cloud is the place in which we have virtually unlimited resources, while on the edge we have limited resources. And on the other side, the edge is better, not only because we don't have the latency, the affection of the latency, but also because we could have privacy issues. Some data cannot never move from the edge to the cloud due to privacy issues. In this project, we would like, we focused on how to study on how we can merge these two domains in order to improve the data management. And in particular, as shown in this slide, we can assume this is a simplified version of the architecture, and then I take the advantage to invite you to read the papers and the deliverables that has been published in the website. We assume that we have cloud resources and the edge resources where the data can be either stored or computed. And we have two main actors, the data owner and the application developer. The data owner is the one that proposes, generates the data and is in charge of creating those data, probably from some machineries, for instance, in the Industry 4.0 scenario. And we assume that we have a lot of application developers which are in charge of consuming those data. So the data owner is in charge of managing the whole life cycle of the data manager, while the application developer is mainly interested on the consumption of this data. As we said, if we stay on the current state of the art, we can have problems related to the privacy, to the scalability of the issues, depending on where the data are stored or where the data are managed. For this reason, we introduce as a key element the concept of movement. In particular, we focus on two types of movements: the computation movement and the data movement. So in other words, we assume that our architecture is able to autonomously move either the computation where the process of the data happens and the storage can be moved from the edge to the cloud and the vice versa, also considering the devices that could be live in the middle between the edge and the cloud. As a main objective, as already mentioned by Eric during his presentation, is to make this technique automatically working without limiting the intervention of either the data owner and the application developer. Because our final aim is to make the life easier for the software developer that doesn't have to take into account all the intricacies of the different devices that has been that could be involved, the different elements that are influencing the quality of service and the quality of data, but to provide an autonomous system. For this reason, in order to enact this data movement, we create a complex architecture that goes under the name of Data SDK and the Data's execution environment, which are able to create what we call the virtual data containers, and that I'll give you some details later on. The SDK is in charge of defining the virtual data containers, and the Data's execution environment is in charge of instantiating those containers and to manage the life cycle of these containers, also including the possibility to move data and computation. Based on this, before introducing the details of these two elements, the SDK and the execution environment, I would like to introduce another cornerstone of the project that is about the data utility. The data utility is defined as the relevance of a given data to the user's context. So this means that given a data owner that exposes the data, not all the application developers or the final users, in our case of this data, are happy, let's say, with this data. For some of them are more interested on some quality aspects like the completeness rather than the accuracy and the precision, so more related to the data quality. Some others are more interested on the quality of service. Some others in the mix between the two. So the data utility concept has been developed inside the project in order to propose a framework for defining this relevance of data based on three main dimensions: the data quality, so dimensions like that are able to evaluate the suitability of the content with respect to the specific application. On the other side, the quality of service, which usually can be, let's say, just to simplify the discussion, to the performances of the data access, and then the reputation that is related to the usage, the past usage of the sources. So in this way, the application developers can select which is the data owner that is more interested from him or for her with respect to the requirements that is able to express. So in some way, we are introducing, in addition to the fog computing and the data-intensive application, also a third element that is based on a service-oriented architecture, where we see the data offering as a data as a service, and where the application developers, many application developers, can look for one or more data services, and then we have to create a kind of marketplace. In order to make this system working, we have a second main concept that we have to introduce before, that is about the data containerization. Why we need this? Because usually when the data owner has to expose the data, it has to take into account several elements like how to process the data, how to expose, how to hide the complexities regarding the devices that have been involved in this data generation. In our approach, we create what we call the virtual data container, and the virtual data container is an element that containerized this effort in a common framework, which exposes the data using what we call the common access framework that is based on a REST interface. Inside the VDC, we have the data processing as well. So all the process of this data can be embedded inside this container. And then we have an interface with the existing data sources. So in this way, we have decoupled the data sources where the data that has been generated inside the organization will be stored with respect to the layers that provides in a container those data after processing to to the application. And it is important to highlight that inside there, we have also a privacy enforcement. So it means that depending on the application or application developer that is looking for the data, the location and the characteristic of these application developers, the policy enforcement can decide to hide or to expose those data to the final user. Then, based on these two main concepts, the data utility and the virtual data container, I can just give you very few details about the SDK and the execution environment. About the SDK is the element, the component that is in charge of managing the life cycle of the VDC based on an artifact that is called Abstract Virtual Data Container Blueprint. This blueprint has the role of describing the VDC, so it can be used by the data owner to express which are the capabilities offered by the data that has been exposed in terms of which are the data, the characteristics, the level of data utility, and so on and so forth. And on the other side, it can be used in order to compare the requirements posed by the application developer in order to create an environment that is able to perform the matchmaking between the requirements and this offering expressed in the blueprint. About the Ditas execution environment, the second main element that composes our architecture. We can imagine that every time an application developer asks for the data exposed by a data owner, a VDC is created. A VDC based on the description of the VDC blueprint is instantiated and it will run in a controlled environment. This controlled environment will be available for all the users of this VDC. So it means that we can have several VDCs for each of the users of this data source. And then the Ditas execution environment includes also a VDM in order to mediate with respect to the different possible clashing requirements that the VDC has to enforce. For this reason, the VDM is organized as follows. Let's see. We try to explore the main elements of a virtual data manager. The virtual data manager is an element in which we are able to, first of all, monitor how a user will consume the data exposed by the data owner. So there is a monitor element. Then there is a decision system that is able to understand if all the requirements, the agreement between the consumer and the provider is fulfilled, and in case they are not fulfilled, they are able to enact either data or computation movement in order to solve this critical situation. This decision system is guided by the data utility evaluator. The data utility evaluator that based on the monitoring data is able to understand which is the level of data utility, and in case it's not sufficient, these adaptation actions are required. Very quickly, in case of computation movement, we assume that the VDC can be moved from either cloud resources to the edge resources and vice versa, exploiting the facilities offered by Kubernetes. The VDC is a container in terms of also Docker containers, and can be moved from one domain to the other domain, exploiting those characteristics of these orchestrators. It is even more interesting if you consider the data movement. In this case, we need to control other type of problems, in particular the consistency between the different replicas. Because if we assume that the data that are currently used by a VDC has to move from one side to another, probably closer to where the user is consuming the data, then the data movement, an actor can decide to replicate that database on the premises of the application of this user, so closer to the VDC that is using those data. So in this case, we need to find out a way to quickly create a replica on the other side and to maintain this replica. And in the project, we are dealing with all the problems in creating this fast replica, especially if we have huge databases. We have also the opportunity, and this is with the last slide of my presentation, and we have also the problem of considering the possibility that we need to move not the complete database, but also a subset of the database related to the specific data set that are allowed for this final user to be seen with respect to the privacy policies. And in this case, it's even more challenging because we need to maintain two replicas that are not complete replicas, but also a partial replica. Everything inside a Kubernetes environment. I conclude with this slide my presentation. I will give the word back to Anna Belen, and would like to say thank you for the attention.
Thank you very much, Gigi, for your presentation of the project outcomes. And now I will give the control. I will give the control of the screen to Aitor, that he's going to show and present to show his slides and present the Industry 4.0 use case.
Yeah, hello everybody. Okay, I think you can see now, right? Yes. Hello everybody, this is Aitor from IDEKO, and yeah, we're bringing to Ditas a real use case based on the Industry 4.0. So first of all, I will follow this index. First of all, I will try to give you an introduction of who we are and to contextualize the use case to be more understandable to everybody. What do we do and well, who we are. Then I will try to show you our work and common problems, those problems that Ditas can or promises to solve. And then I will show you the use case we have prepared to demonstrate the whole framework. And finally, a summary about what is Ditas giving us in the end. So first of all, who we are a research center specialized in manufacturing and industrial production technologies. So we are a research center, that's the word, and focused on manufacturing, right? We have 4 research groups, 4 lines of research: dynamics and control, design and precision engineering, ICT and automation, and manufacturing processes. And we have several facilities that help us to move forward, to make research, and to test everything. The most important maybe is the picture in the bottom right of the screens that shows you our shop floor, our digital grinding innovation hub. Then we give it where we have several machines and we can test everything we develop to improve the machines. So very important too, we are part of Danobat Group. And what is this? Danobat Group is a group of companies that build machine tools. So it's very important. They build machine tools, and we belong to this group. So what kind of machines do we build? Do we assembly? Well, I will show you some examples. Here you have a bedtime milling machines from one of our brands, Soraluz. Here a multitasking milling and turning center, also for Soraluz. Here you can see a laser cutting machine from another brand, Danobat. And centerless grinding machines, also from Danobat. And finally, we have an horizontal boring machines. Those are only some examples of the wide variety of machines that our group builds. So we have these machines all over the world, working in several clients and manufacturing parts for very, very different industries. So, for example, aerospace, railways, energy sector, automotive, and well, so on. So, in summary, at IDEKO, we capture, develop, and generate new knowledge capable of responding to current and future challenges. And at Danovat Group, they try to apply our innovative technologies in the development of matching tools. So everything fits now, right? And all of this because we have a simple objective that our clients ask is to keep the machines working the most of the time in the most efficient way. And everything is for this. We make research, we try to give our group the latest innovations in order to keep the machines working, in order to for them to work better to improve the efficiency of them. And for this, it's very important. We need data. We need data to perform our analysis. And for this, we have our smart box. Our smart box is a box from a company that we own, that it's attached to the machines and easily gather all the data out from the sensors and also from the CNC and PLC of the machines, and we can easily build this kind of dashboards, and we can also get use the data for other analysis and so on. This smart box, as I say, is attached to the machine. We read the data using specific CNC libraries and also libraries for reading sensors. We send it to the cloud, so we have the data in the cloud from all the machines in a plant. We are simulating here a plant with 3 machines. The box also is giving us an API for streaming data. We can anybody in the plant can perform any analysis using the data live from the machines. And we also have an InfluxDB database right inside the box. So we store here the data we get from a single machine, while we store in the cloud the data for all the machines. Okay, it's very important this to understand then the use case. So we have edge and cloud, and it's with its pros and cons. So because as everybody knows, the edge is faster or can be faster, but has low latency, which is good, but is sometimes less reliable and usually has less computing power, while the cloud has way more computing power or has infinite or almost infinite storage capacity and more scalability, but is far away. And well, what this means this has several drawbacks. So when we have to develop an application, we have to take decisions because we have several data sources. We have data sources at the edge and at the cloud, and we have also bare metal machines at the edge and at the cloud. So we have to take decisions. We have to choose the right place for each of the applications we develop. So also developers must manage data sources connections if they want to get data from more than one database, to check whether one database is up or not, and connect to one or other to keep the availability high, or they have to compute data quality metrics. Perhaps one database is down and it doesn't have the amount of data that the application needs at a certain point. They have also to manage the computing resources. If we place the application in a smart box, it doesn't have usually a lot of computation power, so you have to be very smart enough to manage these resources in a proper way, or otherwise you have to move the application to another instance where it will run better. But this must be done by developers always, and they have also to deal with response time requirements. If one of the boxes are very stressed and it's having a hard time, perhaps the application is not responding in the time it's required to, and some other things they must be working on when developing an application. So we have the edge and the cloud. We have the smart boxes here. Also, we have the databases here, and in the cloud we have big servers and big databases. And now the fog comes into play, because clients are usually giving us or providing us with some resources in the plant. So we have now filled the gap between edge and cloud. And well, does this solve some problem? Okay, well, what this do is to add more options to more places where we can run applications. So we have to now to take more variables to take decisions, because we can run the application right at the edge, in the fog, or in the cloud. And this is for a single machine, but in a software we usually have a fleet of machines, each one with a smart box. Some of these boxes have different characteristics, different specifications. Some of them has more computing power, more CPU, more RAM, more or less capacity. So, and sometimes some of them are more stressed than others. So, good and be nice to view the whole fleet, the whole the cluster of smart boxes as a single computation unit. It could be nice, right? Because we could run things in one when one of the box is not stressed, and we could move to another one when the previous one was stressed. You know, all of this is that Ditas aims to solve. So these are the problems we have in our day-to-day work, and some of them, or most of them, so Ditas is proposing to solve most of them and some of these challenges. And well, that's why we are involved in the project. And for the demonstration of the powerful Ditas framework, the following is the use case that we have prepared. I will try to describe globally the use case, and then I will go step by step on what an end user of Ditas must do to get started with the framework, to get an application up and running. So the use case will develop an advanced technical service application to detect anomalies in real time. That's the main thing, detect anomalies in real time. This will be useful for our technical service team that can monitor client machines right from here, and also for clients that can monitor their machines in real time. So the objectives of the application will be to reduce diagnostics time, to decrease response time, to decrease travel costs, because if we are able to detect anomalies right from here, we don't have to send anybody to the client premises in order to make further investigation. And we can also prevent failures of other machines if we are able to compare machines among them. So in summary, an application focused on the technical service teams and 4 main pillars: live data streaming. The application will need data in streaming in real time and be processed in real time, because we will perform real-time anomaly detection. We will run their some anomaly detection algorithms. Automatic data quality assessment. We have data in several databases. The framework should be able to assess the quality of that data in order to give the application the proper data in the right moment. And we will show up some real-time alerts to users and technical service team. So, which are the steps that a user of the Ditas framework must do in order to get an application up and running? So, first of all, as G said, we have kind of 2 roles: data owner and a application developer. In our case, we fulfill both of the roles because we are data owners and usually we are also the application developers. So the first step is to expose the data. And this is done using the virtual data container, as Pierre explained before. And where is this? In our specific case, we have done this using Node-RED. This can be developed in a variety of technologies. You only finally need to have a Docker container exposing some API. That's the only constraint you have to keep. And we decide to do it using Node-RED. So first of all, we have to define the methods available. These will be the methods that any application could call, okay? And we decide whether we expose methods that respond with raw data or we develop methods that make some great things inside, great computations, and responds with already filtered data. That's on our hands. Then we will execute there an anomaly detection algorithm, as I said before, everything inside the Node-RED container. And finally, we have also to expose some metrics for downstream calculations that Ditas framework does, because Ditas needs some metrics in order to measure how is the BTC behaving, to decide whether it must be moved to another machine or whether the data must be moved or what, to fulfill the Ditas magic. So in our case, we have defined a virtual data container that exposes only two methods: get simplified diagnostic and get full diagnostic. One of them is only for the technical service team. The second one that gives the user a more deep view of what is going on the machine, and the first one, get simplified diagnostic, is more for the client. And the client will have a simple view of the machine. And finally, with the virtual data container, it's very important to know that the virtual data container is not aware of data sources. From the Node-RED flow, we just ask for data, and we are not aware on the connectivity with data sources, on where the data sources are, on checking errors, anything. We just ask Ditas for data, and Ditas will try to fulfill our needs of data with its magic, okay? And we also are not aware of computational resources. We just define the BTC, and then Ditas will decide where it runs. That's for the first step. The second step consists on publishing the blueprint. The blueprint tries to describe what we develop in the BTC in the first step. So it's just a JSON file where you define the data sources, where you define the resources provided by the data owner. We as data owner can have resources available, in our case, in the cloud. So we can say, okay, developer, if you use this BTC, you will be able to use the resources we have in the cloud. So those are defined here. Of course, we list the BTC methods that matches the methods I explained before, and we point to several containers that makes that comprises the framework, and some other things, some other minor things. And this is for step 2. And with this, we are publishing our data in a kind of a data catalog where developers can access, search for, and deploy. Then the application developer, now we are moving from the data owner to application developer, then the data owner has to define the application requirements. Okay, now that we have the data published somewhere, some developer comes, wants to develop an application, and the first thing that must be done is to define the requirements of the application. And here it's also a JSON file. We define any functional or non-functional requirements that our application must fulfill. First of all is to say, okay, use this blueprint. That means use this BDC, which means use this data. And there we define in particularly in our case, the response time we need, the availability we need, the security we need, and so on, more metrics. So here we are forming a contract, and service level agreement contract. And Ditas has a component, the service level agreement manager, that will be continuously monitoring that this SLA is getting fulfilled. And when it's not fulfilled, Ditas will try to make some movements or computation or data to get the SLA fulfilled. So what we say here, Ditas will try at every moment to be fulfilled. So after this, the developer just has to instantiate the application. How it takes the blueprint, and I have to say I missed that everything is supported by the SDK, so we don't have to deal with JSON files, but we deal with some interfaces, okay? And also for this step. So the deployment engine takes the blueprint, takes the application requirements, and deploys the application. That's all. Super easy. Okay. And what is behind these scenes? Behind the scenes, and this is also for our specific use case, we have this architecture where we are simulating a plant with 3 machines. Each of them has a box attached, so each of them has an InfluxDB database. We have this in the customer plant. On the other hand, in the cloud, we have the resources that IDEKO is providing to those developers using our BDC. And we also have the InfluxDB database with the data for all the machines in the plant. Moreover, we have the fog, those resources provided by the customer itself that can be right in the plant. So we have kind of a continuum here. So what does Ditas do? When we instantiate, when we deploy the application, Ditas will place the application somewhere. Let's see that it places the application right here in this box. And we'll be perhaps using the data coming from this database. As I said before, Ditas will check the SLA is getting fulfilled, and when the SLA is not fulfilled, Ditas will move the application to a different place where the SLA will be ensured to be fulfilled. At some other point in time, he will move the application. I was telling you how the application works, how Ditas gets the application up and running. So in a first point, it can run the application at the edge at some. Actually, it could run the application at any resource it's defined. So let's say that he deploys the application here in the first of the boxes, and it uses the data from the InfluxDB in the cloud. So at certain point of time, we are monitoring the SLA. Ditas sees that the SLA is not getting fulfilled, so it moves the application to a fog resource. Then he could also move the application to any cloud resource, perhaps to work with the data that is more close to the computation. And again, at some point of time, it could move the application to any of the other edge devices. And also the same thing happens with the database. It could be moved to any of those of the databases that we provide. So in summary, what is Ditas giving us? I have made here a kind of a resume for each of the most important components for us. So the BDM is giving us data source transparency. Our developers don't have to deal with data sources. They don't have to deal with data connectivity, with the up and downs of the data sources, because it's managed by Ditas in an automated way. The data utility evaluator component is giving us automatic data selection based on data quality metrics. By itself, it's continuously computing data quality metrics in order to choose the best fit database for providing data to the application. The BDC is giving us automatic management of resources. As we show in the previous slide, we can move computation from one instance to another one in a transparent way. And this is done by the BDC. And finally, the privacy and security evaluator and the privacy enforcement engine is giving us data privacy and security enforcement of data, because sometimes industrial data for some clients has to be stored in a more secure, in a super secure way. In the practice, and this is my last slide, Ditas is enabling us to leverage the computing power available through the plant. We have a fleet of machines. If we have a fleet of machines in a plant, we have several smart boxes. We don't have to stick to one of those. We can say, okay, we have several boxes, and Ditas, these are resources for you. You can move the applications around to keep them working in the best way. It's also allowing us to have individually exploitable results, because okay, we can have Ditas as a whole, or we can pick some of that pieces. In our case, the BDC idea fits a lot with our day-to-day work, because it's, as I said before, it's leveraging the power of the developers. They don't need to deal with data sources and so on, and that's for us is quite important. So to have individually exploitable results in our case is very important, and not to be always obliged to be tied to the whole framework. And finally, we can say that working with Ditas, we have kind of a standard for developing data-intensive applications, as the whole process is guiding us. We define the data we have with the BDC, then we publish the blueprint, then we instantiate things. So we have kind of a step-by-step for developing data-intensive applications, what in our case is really, really important. And these are my last slide. This was my last slide, so open to any question.
Thank you very much, Aitor. And then we start with the questions and answer session. I don't know if you have any question about the use case or the project overview of the project outcomes. And please, let's say if you have any question for the speakers.
Hello.
Hi.
Hello. This is Mikel Garcia. I work for a digital company located in San Sebastian. And first of all, thank you for the webinar. And yes, I have a question about the application of the solution or the framework.
Okay, let's ask.
I would like to ask Mr. Aitor about how mature is the project to deploy this solution on a real industrial environment. Thank you.
Well, okay. Perhaps I'm not the proper person to answer this, but Ditas don't have a high TRL. We can say that we have a low TRL. So this is a research project. I think that the results are kind of close to market. And in our case, I have to say that it works. Of course, we have to make more tests, but for our use case, it's working. I don't know, Pierre or Rick, if you can provide more info on this.
Yeah, you're right. I mean, we don't have a clear, let's say, a test on a significant scale in order to answer to your question. The experience that Aitor has presented is based on the work done during the project, so we cannot really estimate the time. For sure, all the work, all the outcomes of the project goes towards the objective of reducing the time for the data owner to make the data available to the final user. But it depends on several issues, the time. Sorry for not really answering to your question, but I think we are not in the on the right side to give you a right answer.
Thank you, Aitor and Pierre.
Okay. Anybody has any question else? No. Well, then here we finish our webinar, and thank you for joining this first Ditas webinar. This webinar will be published and the slides will be published as well in the Ditas YouTube channel. Please stay tuned for the upcoming Ditas Solution for eHealth webinar that is planning to be holding in September, and follow us in social media and visit our website. And if you have another questions or you want to contact with us, let's contact through the website. So thank you very much for attending this webinar, and thank you Gigi, Enrique, and Aitor to present this webinar, and all for attend. All of you for attend this webinar in summertime. Okay, thank you very much.
Thank you all.
Thank you very much.
Thank you. Bye-bye.
Bye-bye.